Hello, in this presentation we're going to be discussing mainly RISC and CISC processor architecture. We're going to be defining each one, highlighting their main characteristics, and at the end we're going to be comparing them. First, let's define what a microprocessor is. A microprocessor is a single chip implementation of a computer processing unit, or the CPU, which is the main part of the computer. It's a complex integrated circuit comprised of millions of transistors, and it's capable of processing millions of instructions per second. There are 5 key types of microprocessors. There's the CISC, the RISC, the ASIC, or the application-specific integrated circuit, which is not designed for general purpose, the superscalar microprocessors, which perform various tasks at a time, and the DSP, which are responsible for converting from digital to analog and vice versa. First, let's discuss RISC architecture. RISC stands for Reduced Instruction Set Computer. The modern concept of RISC dates back to the 1980s, and it's a CPU design strategy or approach with the aim of simplifying instruction sets to give higher performance. Now, what this means is that rather than having a complex command or instruction, RISC employs a highly optimized instruction set. The instructions are simple and fast to execute. This reduces the cycles per instruction, but at the cost of the number of instructions per program. Therefore, we'll end up with a rather long program, more instructions, but each one wouldn't take as much time to execute. In fact, it only takes one clock cycle to execute each instruction. Also, it does register-to-register operations, meaning access to memory is very limited. In fact, it's only limited to store and load instructions. Here is an example of how an instruction would look like in RISC. For example, the multiply command, which actually didn't exist in the early implementations of RISC processors. Multiplying two numbers in two different memory locations, for example, we would first load the contents of memory address 2 into A, then load the contents of memory address 3 into B, multiply these two registers, and then store this product into memory address 3 again. Well, for adding R2 and R7, which are two registers, would simply add the contents of R7 to R2. See how operations are only executed through registers rather than through memory, and this saves time. For examples of RISC processors, you usually see them used in portable devices due to their power efficiency. They have relatively low power dissipation compared to other architectures. For example, the Nintendo DS uses 32-bit RISC CPU, and you could also see them in Apple iPods. Now let's move on to discuss more characteristics of RISC architecture. For one, since RISC only does register-to-register operations, you can guess that a large number of registers will be found in a RISC processor. They could include parameter or common registers, local registers which cannot be shared between other modules, and temporary registers. Also, these registers can be used in any context in a RISC processor. Also, RISC processors are pipelined, meaning that at a single time there are several instructions which are in different phases of execution. This is a very important function. And also, RISC has fixed length instructions generally, meaning no time is wasted to determine the length of instruction, and regularity is achieved. MIPS architecture is one of the most popular examples of a RISC architecture. MIPS has 32 general purpose registers, used for different purposes. Each register holds 4 bytes or 32 bits of data, which is a word. Also, the instructions are of a fixed length, 32 bits. There are 3 different formats, used for different types of addressing. As it is RISC, it implements each instruction in a clock cycle. As you can see, the key features of RISC are found in MIPS. Fixed length instructions, lots of general purpose registers, pipelining, and most importantly, a reduced instruction set.
Today I'm going to talk about the CISC architecture. The CISC is an abbreviation of Complex Instruction Set Computer, and it is basically a computer where single instructions can execute low-level operations such as load from memory, an arithmetic operation, and a memory store. First, it was designed by early computer architects who tried to design instruction sets that directly supported high-level constructs such as procedure calls, loop control, and complex addressing modes, allowing data structure and array to be combined into a single architecture. As we see in this example, we see a CISC architecture in figure 1 versus a RISC architecture in figure 2, and we can see that the CPU is directly connected to the program and data memory in CISC, unlike the RISC architecture. In the CISC architecture, you can explore program memory and make any operation on data memory by means of CPU because it's directly connected to it, while you can't do that in the RISC architecture, and that's why you use the store and load word instruction. And that's why the CISC architecture supports load and store memory using single instructions, because the CPU can access program and data memory to easily execute those instructions. As for the CISC architecture features, here are 5 features we should look at. First, CISC chips have complex instructions. For example, CISC has a specific function implemented called mult. This instruction loads 2 values into specific registers, multiplies them, and stores the product in an appropriate register. Mult is known as a complex instruction because it operates directly from the computer memory bank and doesn't require calling, loading, or storing functions. Second, CISC chips have a variety of instructions. These instructions are complex and thus make smaller assembly code. CISC machines generally make use of complex addressing modes, in which operands can be addressed from memory and as well as located in different registers of the CPU. Also, and fourth, um, CISC has easier compiler designs because the complex instruction set and smaller assembly code means little work for the compiler, which leads to an easy compiler design. Finally, CISC processors have a limited number of registers, and that is because CISC's addressing modes use memory operands.
The VAX architecture was first introduced on October 25, 1977 by the Digital Equipment Corporation, DEC, and it was first introduced by VAX 1178. The VAX architecture was a CISC type architecture, which means it had complex instruction set, which means its instruction set may vary between bits and other things such as opcode. This architecture was capable of multiplying polynomials with little software because it was built in the hardware. The emphasis was on the hardware. And this architecture is a 32-bit instruction set architecture, but things may differ between instructions, such as opcodes. For some instructions, the opcode may be 16 bits. For others, it is 8 bits. Also, 2 types of instructions were E-mode, which was capable of multiplying extended multiplication and integration in floating point arithmetic of 2 numbers, and the poly instruction, which was capable of evaluating a polynomial. Also, this architecture has 16 registers, 12 general purpose registers, and register 12 was the argument point register. The VAX procedure uses a data structure termed an argument list. So AP contained the address of this data structure. Register 13 is the floating point current frame point, which contained also another data structure. Moreover, SP is the stack pointer, which contained the address of the top of the processor defined stack, the stack pointer register, and R15, which is the 16th register, is the PC, which contained the address of the next instruction in bytes. to close, we will do a comparison between RISC and CISC architectures. In RISC, the emphasis is on software, and in CISC, the emphasis is on hardware. Instructions in RISC are reduced, instructions in CISC are more complex. Instruction execution is done in pipeline in parallel in RISC because each instruction needs only one cycle to be executed. While in CISC, the instructions are done sequentially because the instruction needs more than one cycle to be executed. However, because the emphasis in RISC is on software, coding or programming, RISC architecture requires more complexity, while in CISC it is more simple to program or code in high-level language. Relative design time RISC is to design a RISC architecture, it's quicker than to design a CISC architecture. And finally, RISC is more efficient than CISC due to its simple instructions. To conclude, RISC is perceived by many as an improvement over CISC, so they prefer RISC more. That's it for the presentation, and thank you so much.